What's up, team? Today we're talking angle addition as well as angle bisector. See the learning target above. I can apply the angle addition postulate and use the definition of angle bisectors to find angle measures. We're going to do that today. So remember a few things here. The angle addition postulate is just like the line or the segment addition postulate, but we're doing it with angles now instead of lines. Bisector is kind of like a midpoint. So we've done all of these sorts of actions before, but now we're going to do them with angles, and last lesson we did them with segments. So as a reminder, here's a line segment, and the segment addition postulate essentially says this. If you take two chunks of a line and you add them together, their measure is going to be the length of the whole entire line. So for this one, AB plus BC equals AC. This chunk plus this chunk equals the whole thing. Same is true with angles. This is the angle addition postulate. I'm going to share it to you with pictures. So if we have this angle A, B, D, and we add it to the angle measure of DBC, we will get the measure of ABC. So let's capture that real quick. The measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. Okay, we're going to do an example of this in a moment. Okay, here's our example. I assigned some angle values here, or angle measures here. Angle ABD is 21 degrees. Angle DBC is 98 degrees. And so when we add them together to find the measure of ABD, we learn that ABD is, oh gosh, is that 119 degrees. So if we take the two chunks of an angle, add their measures together, you're going to get the measure of the whole entire angle. That is the angle addition postulate. Okay, here's another example. This time it's delivered to us like this. We don't have a picture. We have to create the picture. If you're ever given an example like this, draw the picture. Don't try to just think you got it. I draw the picture every time, and I've been doing this a little bit longer than you. So we have the measure of this angle ABD is 55 degrees. And the measure of DBC is 12 degrees. Notice they have the same vertex because the B's are in the middle. Also notice they share this ray here, BD. They both have BD in it. So to draw this, I would make my large angle, whatever it is. Don't know the measure, don't really care. I'm making it large so I have room to write things on the inside. That's why I chose an angle like this. We're going to have some ray coming out of it. We know that the vertex is B. And because they both share this leg D, that's going to be the one that's in the middle. So this one has to be the D. And then the A and the C, it doesn't really matter which ones where they go. I'm gonna do it like this, so I have A, B, C in order. Okay, so now we know that the measure of ABD is 55 degrees. In our picture, that's right here. And DBC is 12 degrees. DBC is 12. So you'll notice my picture is not drawn to scale. That's not 12 degrees, that's not 55. The 12 is bigger than 55. Oh well, like we have a picture. Now we can visualize what is going on. And so the question asks, what is the measure of angle ABC? Well, ABC is the whole entire thing. That's just 55 plus 12. So the measure of angle ABC is 77 degrees. That's not true. It is 67 degrees because 55 plus 12 is 67. Let's move forward. Angle bisectors. This is a new term for us. This is the one that's kind of like the midpoint. So an angle bisector is a ray that divides an angle into two congruent angles. So as a picture, here's our generic angle. Don't know what the measure is, don't care. We have some ray, and if we're told that this ray is a bisector, that means that this angle and this angle have the exact same measure, or this ray chops the whole thing in half. So if this is x degrees, then this one is also x degrees. All right, say we have an example like this. Ray LM bisects angle NLO, and the measure of angle NLM is 32.5 degrees, and we're asked what is the measure of angle NLO. Yikes, okay, so draw a picture. I don't know what's going on here. Let's draw the picture. So we have some angle NLO. Let's draw it. Boom, boom, don't know what the measure is, don't care. N, L, O. We know that LM bisects this, so it's coming from L, which makes sense because we're given the notation here. I'm going to try to do my best. This is right in the middle. It's supposed to be anyway, so this angle is congruent to this angle. They have the same measure. That ray LM chops the whole thing in half. Okay, we are told that NLM is 32.5 degrees. NLM, so that's right here. This is 32.5 degrees. Now, because we know that LM is a bisector, that means this side is also 32.5 degrees. That's by definition. If this side is 32.5, this one is also. They have the same measure because it's bisected. That's given to us. Now, to find the measure of NLO, that's what we're asked for, we are just going to do 32.5 plus 32.5, and we learn that the measure of angle NLO equals 65 degrees. Boom. All right, 2 more examples for you. This video might be a little bit longer if you want to cut me off now. If you don't want these examples, okay. But I got 2 more. They're going to get progressively more challenging. So here's the next one. P is in the interior of angle XYZ. The measure of angle XYP is 25 degrees. And the measure of angle PYZ is 50 degrees. Find the measure of angle XYZ. Okay, again, I don't know what this is saying. I need to see a picture. Let's draw pictures. Here's my generic angle. We know that the whole thing is going to be XYZ and P is in the interior. So we're going to have X, Y, Z. Now this phrase up here, P is in the interior. Where does it go? I don't know. We're just going to guess. We're just going to put it out there. And again, our picture is not going to be perfect, but it's going to help us visualize what is going on. So interior means somewhere on the inside. How about right there? That's a good place for P. And we're going to have something like this. And that's our point P. Now, let's fill in the information that we have. We know that the measure of XYP is 25 degrees. XYP is 25 degrees. Remember that P is not a midpoint in this particular problem. We were not given that information. It'd be cool if we were. It'd make it a little easier for us probably. But P is not the midpoint, so we can't just double this and say the whole thing is 50. But we do know that the measure of angle PYZ is 50 degrees. And if we want to find the measure of angle XYZ, well, we're just going to add these two together. Now that we have the picture, it's clear as day what's going on here. So the measure of angle XYZ is 25 plus 50, which is 75 degrees. Here we go. All right, one more. The last one's going to be a little bit more challenging. Okay, last one, fast one. Let's do this. We know that ray QP bisects angle DQL. Oof, okay. We know that the measure of DQP is this expression, the measure of angle PQL is this expression, and our mission is to find the measure of angle DQL. Okay, again, let's draw pictures. Big angle, lots of space. This big angle, we know that QP bisects DQL, so DQL. QP bisects it. Let's try to make that pretty much in the middle so that these two sides are congruent. They have the same measure. We know that the measure of DQP is 5x minus 7. DQP. So this is 5x minus 7. Normally we throw it in parentheses and put the degree sign. That's common notation. The measure of PQL is 11 plus 2x. So 11 plus 2x. And again, it's degrees because we're talking angle measures here. Now, our mission is to find the measure of angle DQL. Well, it'd be cool if we could just add these two together, and if they were whole numbers, we'd be done now, right? We don't have that. We got to solve for x. So to solve for x here, what we're going to have to do is set these two expressions equal to one another. We know that this angle measure is the same as this one, so we have 5x minus 7, and we're setting that equal to 11 plus 2x. And I think you can see where those two came from. So now we just need to run through, do a little bit of algebra 1, and get the x by itself here. So first I'm going to subtract 2x from both sides, so we learn that 3x minus 7 equals 11, add 7 to both sides, 3x equals 18, and then x equals 6. Okay, cool. We're not done yet. This question doesn't say anything about x. Our goal is not to find out what x is. It's an intermediate goal, but it's not the ultimate goal. So let's take this x equals 6, let's plug it into this, and just for funsies, we'll plug it into the other side as well. When we plug it in for angle PQL, we learn that the measure of PQL, measure of angle PQL, equals 11 plus 2 times 6. So 2 times 6 is 12, plus 11 is 23 degrees. Now on the other side of things, the measure of angle DQP equals 6 times 5, which is 30, minus 7 is also 23 degrees. This should not be a surprise because both the angles are congruent. Of course, they're going to be equal to one another. Now, let's address the final question. Running out of room, we're going to go up here. The measure of angle DQL is 23 plus 23, which is 46 degrees. There we go. We use the angle addition property by adding angle addition postulate. We added both the angles together, and we utilized the fact that this is a midpoint. So this encompasses the entire lesson in one problem. Okay, let me know if you have questions. Best of luck.